Hello, everyone. I'd like to welcome you to the Open Voice Network's interoperability protocols for interoperable assistance. And I hope you'll find, very grateful for your attendance today, and I hope you'll find this informative and interesting. The webinar is presented by the Open Voice Network Architecture Work Group. I'll be your moderator. I'm Deborah Dahl from Conversational Technologies, and we have two very exciting speakers, David Atwater from TalkMap and Emmett Coyne from Edge Talk. We can go to the next slide. This is a meeting of the Open Voice Network. It operates under the rules of the Linux Foundation. The meeting is recorded. It will end on time, and it's being conducted in accordance with the antitrust guidelines of the Linux Foundation. So let's move on. This is just a quick overview of our agenda. We'll tell you about the Open Voice Network. We'll tell you about our interoperability vision and our work on interoperability. We'll demonstrate interoperability with two independent conversational agents. And then we'll give you a look at the dialogue event specifications that underlie the demo. Talk about how you can get involved, and we'll have a chance for everyone to offer their suggestions and comments. Today, it's a big day. We'll unveil our definition of our proposed specifications for delegating dialogue events. And we'll talk a little bit about what that means in a second. This is a key building block for agent-to-agent interoperability. Let's go to the next slide. I wanted to say a little bit about the Open Voice Network. Many of you are probably familiar with it, but I wanted to emphasize that we have two major thrusts in our work. The first is a technical thrust. It's voice that works like the web, and we'll see that how that works shortly. That's going to be based on our technical standards that you'll be seeing a lot of during David's presentation. Our second thrust is voice worthy of user trust. And we won't emphasize that today, but I would encourage you to look into our webinar next week, which will be discussing our Trustmark initiative. And that's going to be a great webinar that I would encourage everyone to come to. Well, let's move on to the next slide. We want to ask why do we want conversational assistants to be able to interoperate or collaborate on users' goals? I think we all know that people are rapidly adopting conversational assistants, both for kind of generic tasks that you might do with a smart speaker or something like Siri on your mobile device, but also for enterprise information. So it's clear that not any single assistant can do everything that a user might need, but at some point it's going to reach the limits of its expertise. And what we have now, the user just has to say, okay, I can't continue using this assistant anymore. I have to find something else. Our vision is that shouldn't be necessary, that we should have interoperable assistants that can pass on a task to another assistant to help the user realize their new goals. To do that, assistants need to be able to talk to each other. They have to have a common language, which is a standard, and that's what we're working on. Next slide, please. Well, we have to address the elephant in the room, the large language models. And it's easy to think, a lot of people do think that they solve everything. We're talking about things like ChatGPT. In fact, large language models will inspire people to get into this industry and create more conversational assistants which have even more of a need to interoperate. Large language models aren't the answer to everything. They don't know information about you. That information is password protected or behind a paywall. They can't get to it. They can't learn about it, which is a good thing. They're also deployed in the cloud. Not every application is suitable for cloud deployment. And there are also millions of existing legacy conversational assistants. They're not going to be converted to large language models anytime soon. So let's look at the next slide. Where we are, we've been working on this for a while, and we've published some documents and some draft specifications for dialogue events, and we've put together a demo that you'll see today. Next slide. We have kind of the foundation of our technical work on interoperability is our interaction patterns. We have 3 patterns. One is where an agent consults behind the scenes with another. We call that mediation. Another one is where one agent speaks for another. We call that channeling. And the final one, which we'll be seeing today, is what we call delegation, where an agent simply hands off the conversation to another. So let's go to the next slide. The first thing we're going to see today is a demonstration of 2 agents cooperating with the delegation mode, and then we'll see the details of the specification. So we're ready for the next slide. Okay, we're going to start off with our demo, and I'm going to pass this baton, as it were, over to Emmett Coyne from EdgeTalk.
Thank you, Debbie. That was a nice introduction. The slides have to continue, though. Nathan, there's the next, there we go. Next slide's for me. Okay, a little overview. What you're going to see is a playground. We created a playground to experiment with the different methods and modes that could possibly be used in delegation and in the other kinds of interactions. These are real interactions. There are multiple assistants and servers, and we're using a prototype of the structure of the event exchanges that David will talk about in more in detail later. So this is again, the assistants are not important what they're doing, it's how they interact with each other that we want you to understand. Our model of operation is that it is a World Wide Web of assistants. It's like pages in a browser. You can go to any page on the web. You should be able to go to just about any assistant on the web. Next slide. What you're going to see. A few things. We're going to show you a server window, a client window, and some of the OVAN events that David will talk about later. The first thing you'll see is a very simple delegation scenario, and I won't explain it or anything. It'll just be a quick, fun thing, and it'll give you the feel of how we expect these things to operate. Then there'll be a more grounded sort of scenario that I will stop at points and do a little bit of a walkthrough, a little bit of a discussion what's happening. Then I'll follow up with an in-depth view and a discussion with sequence diagrams, and you'll see a bit of the architecture that's being used to implement this. So now at this point, I can take the screen. Okay, so as you can see my screen, what you've got here on the left is several colored windows. These represent the agents. Each one is an independent server using only HTTP to communicate. They could be anywhere on the web and they'd work just like this. The first agent we will talk to is in this purple box. A second agent will be in the blue one. Later we'll talk to the green one. So let's just dive in and see how it works.
Cassandra here. Welcome to the multi-agent demo.
Hello, Cassandra.
Hello. At your service.
What do you know about martinis?
I don't have that expertise, but...
You're not so secret agent. Bond here.
What do you know about martinis?
A great drink. What do you want to know?
Should they be stirred or on the rocks?
always shaken, never stirred, and absolutely never any ice.
Thank you.
You're welcome.
Let's go back to Cassandra now.
Goodbye. It was fun talking to you. Bye for now.
Hello again. By the way, did you get what you needed?
Yes, that was great.
Good. Back to work.
Okay, now we saw an interesting conversation where the primary agent, Cassandra, knew things about me. I could have asked her, my personal things, but I asked about martinis and she didn't know, but she had a way to find out. We're not getting into those details. That's another spec, but she found out that Bond could maybe answer my questions, and she connected me to Bond. And I asked the questions, I got the work done, and then I came back pretty effortlessly to Cassandra. So let's now look at a more grounded example. This will be Cassandra, the purple one, will be talking to this green server, a totally different server. Cassandra, I need to pick up my prescription.
I will get your registered pharmacy agent.
Ventura's Pharmacy. Hi, my name is George.
Hi, George, I need to pick up my medicine.
Yes, Emmett, I see we have your authentication token here. It is ready to pick up.
So as an aside, this implies that I was connected and that Cassandra already had some sort of a logon information for me, some authentication, and the pharmacy knows that it's me, and I'm a regular there. So let's see, maybe I can do something else while I'm here at the pharmacy. Can you add a bottle of Pepto-Bismol to the order?
We will have the Pepto-Bismol at the window when you do your prescription pickup.
Thank you.
You're welcome.
Can we go back to Cassandra now?
Of course. Thank you for your business and have a nice day.
Hello again. By the way, did you get what you needed?
Yes, I did.
Good. Back to work.
So I conducted some real business. I checked on my prescription. I added something to the order, and that was all done fairly straightforward with the sequencing there. Cassandra, show me the sequence diagram.
Is this the one?
Yeah, that's it. Let's see, I'll make it a little bigger here so we can see it. All right. This is a standard sequence diagram. Each of the columns represents something, me, the human, the red-blooded thing. The neutral thing in the middle is the client that handles the ASR and TTS. And then you'll recognize Cassandra and the pharmacy bot over here. So what happened? I spoke to the web client. I said I need to check my prescription. The client did some ASR. It packaged up an OVON event, sending the ASR to Cassandra, the agent I was connected to. Cassandra did her natural language understanding and dialogue switching, whatever, and came back with a response in an OVON packet again. And the client did some TTS and said, I will connect you to your pharmacy. Then in that packet, by the way, she also knew the address of the pharmacy agent. And so the client was prepared after speaking to connect me through HTTP to this other server, this other assistant. The PharmaBot, and it did its initialization for me, and then it built the greeting, and it sent back another OVON event with some instructions to say something. Did some TTS and said, hello, whatever, Ventura Pharmacy. And I asked about my prescription. Again, ASR is done in the client, neutral thing. Doesn't understand anything except the words being spoken or recognized. It sends the ASR result through the HTTP event again. The PharmaBot understands it. And now the pharmacy is the only thing that understands how these rules work and what my prescription is and other things. So it comes back with a response and it says through the TTS, yes, and it knows that's me and we're all cool. Then I decided to do some pharmacy type work while I was there. I asked to add something to my order. Again, it went back, but now it's also got to do more business rules. For instance, it has a database about what it's got in stock and whether it can put that in my order or not. So whatever it decides, it then comes back to the client, gives me another TTS response. Yep, we'll put that Pepto-Bismol there for you. And then I say, thanks, and can you send me back to Cassandra? So it packages up that in the HTTP, the pharmacy bot understands, it does its dialogue. It has to recognize now that there's an address for Cassandra and that I want to go back to her. And it generates a goodbye and it sends that connection back to the client. So pharmacy says, pleasure serving you, have a good day. The connection is sent through HTTP to Cassandra, reinitializes, Cassandra picks up where we left off, sends a response and says, it's me, how'd it go, sort of thing. And then the conversation just continues. Just to give you a look at some of the things that are in there, we can take a look at some of them that we are representing. David will talk about this. We settled on JSON. We were doing XML and JSON. Don't worry about this too much. David will explain it in depth, but this is a prototype of the original messages. It's just JSON, and you can see it's got things like words and MIME types and all sorts of things like that. The actual information is embedded in, for this proprietary assistant server, it's got its own way of passing the data, but you can see that embedded in it is a representation of what the OVON events contain. So I think that's a pretty good overview. Maybe I'll pass it back to David.
Thank you, Emmett. That was great. Now, if you're interested in seeing more about the standards that we're developing that underlie it, we'll move over to David.
Thank you, Emmett. That was excellent. What I'm going to talk you through now is, if we can just advance the slides forwards. I'm going to talk you through one of the low-level specifications we're working on as our starting point. The working group is working very iteratively, so we're working basically on building the demos, such as you see there, whilst also in parallel working on writing and standardizing the messages that we'll be passing around. So this is early in the process. We've published a specification of the requirements for this. I'm going to talk you through what they are and give you a glimpse of where we're up to. So first of all, if we can move forwards to the next slide. Let me just explain what a dialogue event is. This is a very fundamental data structure that we're envisaging will be reusable in all sorts of protocols around the interoperable conversational system. It's a standard extensible structure. It represents an event in a dialogue. So whereas for a graphical user interface, an event will be something like clicking a button or moving a mouse or something like that, or displaying an image. In dialogue, events belong to a speaker. They span a period of time, so they don't occur at a point in time. They actually span a period in time, which may be a few milliseconds up to several seconds. And that span then can contain one or more features related to that dialogue event. The features are in what we call layers. So the layers can have different types. So for example, you might have an audio layer, a text layer, a meaning layer, pronunciation. At a later date, there could be things like gestures, pen input, all sorts of things could be in there. Some of these we envisage will be OVON standards. We're planning to standardize the most commonly used ones. But as I mentioned, the dialogue event is customizable. So you can use your own events, or other people can specify standards that can be used within the OVON dialogue event packet, but don't have to themselves be OVON standards themselves. If we can move to the next slide, please. So what would a really simple dialogue event look like? This is perhaps the simplest. I'm just visualizing it here. So we have the event is associated with an individual user. It spans a period of time. It may have a reference back to a previous event, so that things like sequences of conversational chains can be kept track of. And then this has just got a single feature. It's a text type. It's called a user request, and here's essentially an utterance that will be passing, let's say, from one agent to another. I want to apply for a fishing license. Can you help me with that? Well, let's just see how this packet then might be moving around in the system. If we can move on to the next slide. In the simplest form, these packets can be used to literally pass events, essentially utterances. Think of them as utterances or dialogue moves from one agent to another. This is a scenario you've just seen. It's a different story, but it's the same architectural scenario. We have a user interacting with a host client, which is sending standardized packets to agent A, which realizes that it needs to then transfer to agent B. These packets would not be used for the control aspect of what you've just seen, but they would be used for managing all the linguistic information that's passing between the agents. And then that agent B takes over, and then agent B also uses a dialogue event to speak out. So these are not just events from users. That any linguistic event in the system can be packaged up and represented as a dialogue event. So the agent speaking is in just the same framework as a recognition from a user. If we can just move forward to the next slide. I said that these dialogue events, they're a low-level structure that we're envisaging being used in all sorts of different protocols. So here's some of the use cases we're picturing. Passing dialogue events to and from agents, which is what you've seen in the demonstration today. So user requests, system responses, and also agents speaking to one another. We're envisaging that agents will actually, behind the scenes, use natural language to actually ask questions of each other, like, can you help me with this, et cetera, because language is uniquely suited for unstructured responses that are interoperable between people, but also between agents. In addition, dialogue events can be used to keep history. Conversational AIs will want to know conversational history, either within a single conversation or between agents. Generative AI, the large language models that Debbie mentioned earlier, for example, make extremely extensive use of history. And by packaging up a sequence of dialogue events, which may be anonymized for security reasons, we can basically pass history. We can just keep the events as they flow around and then pass them on as history to the next agent so that they know the context of what's happening. Incidentally, and this is something of interest to me professionally, these same events could be used for archiving conversation transcripts, including, for example, transcripts of human-human conversations, such as transcripts of call center conversations or chats between people. So this is not limited to just human-machine conversation. In addition, we've designed the dialogue events so that they can be used also as fundamental events to and from microservices, things like speech-to-text services, passing in, for example, audio and getting text back, or an interpretation passing in text and getting a meaning back. If we can move to the next slide. Here's an example now of a dialogue event that's richer. We'll see at the top, it has the same information we saw earlier. We saw this text feature, I want to apply for a fishing license, but now you'll see we've also added in an audio feature, which in this case is a reference to a file, but it could be some other kind of reference to an audio source for the utterance. We also have a meaning feature, which we'll anticipate will be in a standard format for passing things like slots and intents and frame-based semantic information. And at the bottom, you'll notice we're allowing for any other features to be added in. So your agent can put whatever it wants into a dialogue event and send it to another agent. It could be a standard that's only known to those two agents, or it could be another more universal standard. So if I move to the next slide, here's an example of how these events could get built up. So the endpoint, for example, could generate audio, which is then passed to a speech-to-text engine, which then adds the text feature to the dialogue event, which then gets passed to a particular agent that may then use its own local microservice natural language agent to add a meaning interpretation that's specific to itself, resulting in the packet that we saw on the previous slide. So let's now look at potential syntax. We're still working on this. If you could move to the next slide, please. We are still prototyping and working on this in the working group. We'd welcome any of you to come and join us. Here's an example of an iteration of a message. We're getting very close now to standardizing this. You'll see we're choosing to represent events in JSON, although we're anticipating that there will probably be a well-defined conversion into things like YAML and XML as well. So that can be straightforward. You'll see here we have a representation, we have a speaker, an ID, we have a span, just as you saw in the graphic. We see these various features. We have an audio feature, a request text feature, and an intent feature. And you'll also notice that there are other additional things that are in the requirements for these dialogue packets that they can, in a reusable and open way, link between each other. So for example, you can include links, derivation links that say that this particular intent came from this particular word in this particular text, for example. There could be phonetic layers that are linked to individual words within another layer. There could be pen input that could be, for example, linked to someone drawing a circle around a particular word in an input on a screen. We're anticipating all of those use cases, and that's why we're keeping it as an open layered framework. If we now move to the next slide, I mentioned dialogue history. Dialogue history can be really simple. It can just be a large bucket of dialogue events. Because each event is timed, this doesn't need to be I speak, you speak, I speak, you speak. They can represent overlapping language. It could represent multiple speakers in a conversation. So you could represent 10, 15 people holding a conversation simultaneously with overlapping speech. The format will allow that. And as we mentioned earlier, there's no fundamental difference in our standard between a human and a machine. So we can also have transcripts of people, talking to machines, in any particular permutation. If we can move on to the next slide, please. So just to summarize, as a first step in our standardization, we have this dialogue event, which is a standardized container that can carry standard and non-standard features of data. These will then be embedded within high-level specifications from OVON, and we think they'll also be extremely useful for other people building other specifications related to linguistic applications as well. Our working guiding principle: simple things have to be simple. At the end of the day, if you want to just pass a text prompt from one agent to another, we don't want it to be wrapped up in crazy, crazy layers of extra information. But hard things are also possible. So we developed this concept of standoff annotation between layers that's completely extensible. To allow for innovations in user interface technology and different ways of representing meaning, etc. Agents do not need to know anything about each other to consume the standardized features within these packets. So that will allow a sort of lowest common denominator interworking between any two agents. But agents can also use these dialogue events. If they're highly coupled, they can use their own proprietary features to allow richer interaction. So even, for example, within an ecosystem or between agents that are within a given ecosystem, there could be proprietary non-standard things that are passing around, graphical events, etc., that could be used to enhance those interactions. But the moment those interactions go off platform to another ecosystem, they still are interworkable. It's just that some of the layers become uninterpretable. At the bottom, you'll see a link to the requirements for the Dialogue Events Working Group. This is an open group. We welcome anyone to come and join us in our work. That's it. Thank you very much.
Let's see the next slide. Yeah, just these are both the demo and the presentation on the specifications. They were really awesome. And I wanted to say a couple of things about our our next plans. We've done a lot of work. There's still a lot of work left to do, and so we're going to be moving forward to writing more specifications for some of our high priority capabilities. We're going to continue to enrich and add capabilities to our demos. And very importantly, we're hoping to recruit some external partners to collaborate on testing our specifications with their use cases. So I think we're ready for our discussion. Let's move to the next slide. So if you have questions, I see that some questions have been already put in the chat. Nathan will find some questions and we can all talk about them.
Thanks, Debbie. Looks like we have a number of questions here. Simon Kingamy has a question here. How are you securing the conversation? How can you exclude/include parts of the history? In other words, send the pharmacy history to the pharmacy, but not the others.
I can take this one if you like. We're still working on this. I think we're envisaging probably a few different layers will get involved. At its most fundamental, we're envisaging that there will be a requirement for redaction and anonymization right at the dialogue event level. And this is something I work with. I work in the contact center industry, so I spend a lot of time working with redaction and anonymization of personal information. So we're envisaging even at the dialogue event level, it potentially could be standard. We need to talk it through. Certain features within the events could be redacted. I think at higher level, there's a lot of work going on, not within our team, but in some of the other teams within Ovon, thinking through some of the issues of identity, personalization, and passing permission. Maybe one of the other speakers can elaborate on that.
Well, I think there will still have to be some way of encrypting and encoding and sending the special stuff to the pharmacy. And that we have not addressed that directly, but we do have people thinking about it, and that will be an issue, certainly.
Mm-hmm.
We have another question here from Jay Ashbo. Jay asks, is the pattern of this demo that we showed similar to that of a responsive IVR? In other words, using a navigational tree and routing?
I'm not sure I heard that.
Jay asks, is the pattern of this demo that we showed similar to that of a responsive IVR using a navigational tree and routing?
Interesting. This is just done under the auspices of connecting to different aid assistants, and there is no given tree. The idea is that someone needs some information and it will be discovered somehow. We're addressing that issue too, and then you will be sent to another assistant. It's not built into one big ball of wax. That's the whole idea behind it.
A better analogy might be to think of the way a telephone network works, where individual people make decisions about whether to connect or bridge in or pass on conversation to other individuals, but they've all got their own internal knowledge, and they can all choose exactly what information they pass on to each other, but they have no control over what each other will say.
Janice Mandel asks, she says, cool capabilities. And she asks, how can we consider the source to gauge the quality of the information obtained?
Is that you, Debbie?
So I think what I understand from that question is that when you get information from your assistant, how do we know that that information is correct? And secondarily, how do we know that the assistant is what it purports to be? So, for example, I don't know about correction. We might have differences of opinion about the right way to make a martini, and that's how we have to judge that in light of whatever else we know about martinis, just like we would judge web information. We have, on the other hand, knowing that that assistant is what it claims to be, is another activity that we haven't mentioned today, but it's activity that's just getting started on authenticating agents to make sure that when we go and find the pharmacy, that it really is the pharmacy and it's allowed to have access to my health information.
Leslie Pound asks, do LLMs, large language models with a single interface, perhaps in different locations, and their popularity impact how you see/promote/design this?
I can try answering that. I don't think they make any difference to it at all. LLMs are essentially a technology for potentially building a conversational, well, certainly for building a conversational agent or providing interpretation services and language generation services to a conversational agent. The work that underpins what we're doing is a working assumption that there will not be a single curated LLM that you just talk to. There won't be one big LLM in the world that everyone talks to, and we don't envisage that as a forward future. The LLMs are really a technology. I don't know if my colleagues want to add to that.
Well, I think just from a practical standpoint, my own experience, using the large language models, you can use them to build conversations, but you don't let them control the conversation. You might ask for a number of ways to phrase something, or a number of ways that a person might say something. They're very good at giving you examples of that, and then using this for some sort of discovery of what are they asking for. But I don't think they'll be controlling your pharmacy agent and deciding what to put on your order or not for some time. They're not designed for that. They just predict the next word. That's all they do. They're very good at it. That's all they do.
Laura Miller asks, how's the confidence score given? And is that transparent to users? And should I interpret it to be confident in response? I saw it on one of the code screens.
Okay, so
Well,
oh, sorry, go ahead, Deborah.
Well, I was just going to say we have to we have to make sure that we have a clear distinction between system engineering and system architecture and standards. There are many things that a system can decide to do that are independent or orthogonal to standards. And in my opinion, one of those is how much confidence to expose to the user. I think that's part of a conversational design that is independent of standards. But maybe, I thought David was starting to say something, but
I was only going to say the same as you, but less eloquently.
I was going to add one practical thing to add to amplify yours. The demo that we did was run on an Edge browser. If you run it on a Chrome browser, you get different things. For instance, Edge does not tell you the confidence of your speech recognition. Chrome does. You have to, practical world is going to have to live with the fact that you have different reports from different technologies.
Here's an observation, an interesting observation from Gendra Goel to everyone. He says, I think authentication identity management will need more fields covering various modalities such as password, biometrics, etc. And then will need to be graded by the level of trust also. Any thoughts on that? David, I see you nodding.
I agree. I mean, one of the things that I've actually really enjoyed with being part of the OVON group is that they're paying significant attention to these issues. I'm an engineer, so I kind of glossed over them and just assumed someone else would solve them. But it is becoming really obvious that one of the main values that OVON's adding is really thinking through some of these security, confidentiality, trust issues. And it is a very hard problem because it's multidimensional, as you observe.
I would like to add that we currently have a group working on the authentication of agents, and after that, to begin the work on authentication of users. We would appreciate your joining the group and participating and giving your insights on how you think that authentication work should proceed.
And please don't think we're not worried about the security. what you saw today was just getting something that would functionally work to give you the feel for what's happening. There's obviously a lot more that goes behind this.
Bill Shin has a question as well. He asks, will Proxima Client always be a browser? What else can you imagine?
Oh, it can be, I could imagine it being a phone switchboardy sort of thing with an old phenolic dial phone that just handles, you're talking to it, and it only has to be able to connect to the assistants. A browser is a convenient way to do it, but an app on your phone could do it. There are any number of things that maybe an app on your watch could do it. I don't know, all sorts of inputs.
So
I think
smart speaker would be a good example.
Yeah,
That
there you go.
could certainly be that.
And also historic IVR, chatbot infrastructures as well. We're envisaging all of those as target infrastructures. We're certainly not envisaging only web-based clients.
I think we have time for one more question. Let's go back to Simon Gingaby. Simon asks, is Amazon going to implement this in Alexa, or is this way too early to say? Or can I implement this in my Alexa skills?
Well,
Alexa,
we can't speak for Amazon. I personally think that before that happens, there will be some middleware that shows up that can mediate between Amazon and standards-based communication.
Simon, this is John Stein. We would love the conversation with our friends in Seattle. We've had some conversation and we would welcome continued conversations. And so look forward to that. But thank you for your question.
I think we're about at time here. Do we have time for one more question?
I think we should probably wrap up. Can we save the chat along with the rest of our information, and then maybe we can get back to some of the questions offline?
Sounds good.
So I think I have one more slide. Okay, just to follow up, we'd love to have anyone who's interested in working with us in the development. It's very active, very lively, and as I said, there's a lot left to do. We have a weekly Zoom call, and we have a very active Slack channel. So anybody that's interested in working with us, just let us know. We also have an OVON demonstration program where we give people the opportunity to try out our specifications. You'll have an email address you can use to contact us. You can also contact us on LinkedIn. And if people have questions about the specifications, we'd love to answer those questions for you. We'll have a recording available shortly on the OVON website, addresses for the additional questions, and I hope you'll be able to answer our follow-on questionnaire. I'm so happy that so many of you were able to come and offer such insightful questions, and let's not let this be the end of our discussions. I'm really looking forward to working with you all in the future. John, did you want to say any final words?
I just wanted to thank everyone for their time. Thanks for joining us. And again, the Open Voice Network is about you, and it's about your contributions. It's a communally developed, communally driven effort that's going on here. And so we welcome your participation. Find us on our website, find us on LinkedIn. We look forward to working with you. Debbie, Emmett, David, Jim, Nathan, thank you so much for the leadership today. That concludes today's webinar. Thank you.
Bye.
Bye.
Thank you.